Okay, this time is a proof of calculus identities. I'm just going to do just one question for this part. Okay, it says here, let y equals x power of m, and then p of n is all this, and we have to prove it by mathematical induction. So step 1, prove true for n equals 1. Okay, so I'm going to go left hand side, 1, 2, x1. Now, and then we say y equals x power of m. So I'm going to put, instead of y, I'm going to put x2m and 1. I'm not going to put 1. Oh, I'll just put it in anyway. Now, this is just same as mx m minus 1, as you can see. Okay, but we need to change this one into some sort of factorial term. So, for example, what does that really mean? It's, oops, m. It's the same thing, isn't it? So that's what I'm going to use. Instead of this, I'm going to use this one. So this is over like that, okay? And that means it's the same as right hand side. Therefore, is true. And step 2, assume true for n equals k. Ooh, that'll help if you can see them. Okay, so n equals k, so I'm going to put, instead of n, I'm going to put all the k's in there. Okay, so that's what I've got. That's not too bad. The next one, let me see if I can just keep this one, and then I can continue here. Step 3, prove true for n equals k plus 1. Okay, so I'm going to put in terms of k plus 1 for a whole lot. Plus 1 m factorial k plus 1 . Okay, so I've got that written down. Now I'm going to go left hand side, so I'm just going to rewrite this. Okay. And then remember, step 2, I need to use step 2, whatever I had. So I'm just going to rewrite this one. So when I need it, it'll be there. Okay, that was from step 2. Oops, fallen out, but I got the step 2 here, so it should be okay. All right, so next one, I'm going to go like this. Now you might think, oh, how did you get that, miss? I'm going to show you something. So for example, and if we continue to do this one, squared, yeah, I can rewrite this as like this. Is also same, isn't it? It's that same. So what I've done is I've just written in a different ways. Okay, if you can sort of understand this and memorize this term, you can alternate this. You know, depends on the question. So that's what it is. It's just using the previous differentiation. Okay, so I'm gonna replace that with this. Okay, so now we have to differentiate in terms of x here. So that would be easy because there's only one x there. So it would be m minus k in the front, m factorial, and it will lose 1 power. And then on the bottom will be the same. Okay, there's only one x term here, so we don't have to worry too much there. And when you look at on the top here, only difference is this one has to go. So what I'm going to do here is this. And here I'm going to change this. Cancel out. Now this one doesn't look exactly like what is here, so I'm just going to change this to look a little bit more like what we want, so that it's clear that x plus 1 term is there, which is same as right hand side. Okay, so then I can say pk plus 1 is true, and but p to the power p of 1 is also true. So now we can say step 4, p of n is true by mathematical induction. Okay, well done people.